Let's now talk about a couple of the features that aren't working quite correctly with the AGC furnaces, and we'll get into why they aren't the way they're supposed to be in another video. For the most part, there's no technical reason why these couldn't work. It's more of just a series of events that cause them to either never to work or to be undone, essentially, because they did at one point work. Let's take a look at the different modes. Our heating mode is again where the thermostat is calling for heat and we need to add heat content to the room. So we have two stages of heat, heat 1 and heat 2. And then I also mentioned that we typically have a warm-up mode which says just bring on the heat full works, but close the outside air. Whereas heat 2 is bring on the heat full works, but still continue to circulate outside air if you're in an occupied setting. Heat 1 is add a proportional amount of heat to whatever the demand is, so we don't overheat the space or make it uncomfortable by heating it too quickly. In our furnaces, heat 1 doesn't do anything in terms of heat. It doesn't add heat content to the room at all. Really all it does is it turns on, it enables makeup air. It turns on the modulation system so that we're maintaining a constant discharge air temperature. So the discharge air temperature is going to be a constant, whatever it is that's set on the side of the box. And that's typically going to be anywhere from 55 to 70 or even higher, but I believe we maintain it probably around 60 degrees, 65, somewhere in that area. You just can't really see that. So we're going to say 60 to 65 degrees. Okay. That's all it does. So when it calls for heat, because remember, if the thermostat is over here at 70 degrees with a set point, and we drop down to 69, it's going to call heat 1. But in this case, all it's going to do is just turn the unit on, if it's not already on, and bring in constant air at this temperature. Heat 2 is pretty much as advertised. It's going to be full flame, turns off the modulation. However, it doesn't do anything with the outside air damper in terms of closing it or opening it. It keeps it to whatever the occupied setting is. And in this case, when we get down here and look at occupied, there is no difference, because whenever the furnace is on, it goes into occupied mode. So it's kind of hard to write that down here, but basically anytime we're in heat mode, we're automatically in occupied mode. So even if it's in the middle of the night and we need to have heat brought in, whether it be stage 1 or stage 2, it's still going to open the outside air damper and bring in whatever the minimum outside air percentage is and mix that in. So that's a big energy savings, or a big energy waste really in this case. So heat 2 is full flame, but it leaves the outside air damper open, at least to the minimum percent open. Okay, so that works. Warm-up mode we just simply don't have. So as close as we can get is heat 2, which says it's full flame, but again, you would typically want it to be full flame with no outside air coming in at all, regardless if you're in occupied or unoccupied mode. We don't have that mode at all right now, so that's a limiting factor there. The occupied setting, like I say, is really controlled by the fan mode on the thermostat, which is fine in itself. We have occupied and unoccupied, or perhaps better terms here would be fresh air, and this would just be like recirculate. That would probably make a better sense in terms of like how you'd have it in your car. Typically, you would be able to go back and forth here, regardless of these settings up here, regardless of the makeup air. But it really doesn't matter if you turn the occupied on and we're not having a call for heat. Then none of these will take place. But then we will go into makeup air mode. That also is confusing, but makeup air mode at that point, which it should, because it's going to say, all right, if we're occupied, we have to always have fresh air coming in. So it's going to work correctly and go between makeup air and heat mode, back and forth, depending on if it has to add heat or just maintain the temperature by bringing in fresh air down here. So that one works okay. The unoccupied typically only needs to be applicable when we're in heat mode, because if you're unoccupied, you don't do a make-up air mode. You don't want to bring in fresh air when there's no demand for heat. You just want to have everything just shut off. That part works just fine. The part that doesn't work just fine is if this is unoccupied and the heat mode comes on, it still puts it into occupied. And all that does is, again, this word is a little overloaded. What that really means is the outside air damper. Outside air damper, minimum percent open. And here it should be the outside air damper 0% open. So this would be, for example, like 20%, what might be the minimum here. And here it should be 0. So if you have this set to unoccupied, but it has a call for heat, whether it be heat 1 or heat 2, it automatically opens up this outside air damper to the minimum percentage, regardless of this setting. So that's a problem, because for a church, out of 168 hours in a week, we only use 2 hours occupied. Very little time is the space actually being used where we have to recirculate air. So there's really no reason to heat the outside by 20% for the 166 hours that we're doing nothing but maintaining a setback temperature in unoccupied mode. Unfortunately, every time there's a call for heat, it's going to open up that outside air damper and we start heating the outdoors. So that's a huge energy waste right there. Now, the lack of a warm-up mode is probably not a huge deal because we only go through a couple of warm-ups a week. Actually only one now for a Sunday service, but whenever we're going into a occupied or a room temperature of 70 degrees, for example, from the 55 setback, that's when you use the warm-up mode. Because we don't have one, it just goes into heat 2 naturally because of that big difference in temperature that needs to be made up. It goes into heat 2 mode, which is fine. It only has to do that twice a week. It's probably not a big energy waste that we're bringing in 20% outside air during that time. However, it does make a big difference in terms of the amount of time it takes to warm up the space. Whereas it takes about 2 hours right now with it bringing in all that outside air to do the 15-degree temperature rise. It should only be doing about a little over an hour, since it's about 2 degrees per 10 minutes or so is what it is calibrated to do, I believe. So that's going to be just a little over an hour to do that warm-up. So it's not a huge deal. I mean, it takes twice as long as it probably should, but it's only doing it twice a week. Not a huge deal. The real shame, though, is that every time we have a call for heat, anytime throughout the 168 hours, it's warming up 20% of the outside air. So if it's like 10 degrees below zero, 20% of the air that we're heating is being taken from negative 10 degrees to 70 degrees. That's a huge temperature rise. That's really not needed because the return air would be probably only about 60 coming back out of the 70-degree room. So that's a big difference, and is significant in terms of the really cold winter months. Okay, so far that gives us one gap that we have right now with our furnaces, where the heat 1 doesn't really do heat 1, it just brings in makeup air. 2 is where whenever we're in heat mode, we're automatically in occupied mode or in fresh air mode if we want to be or not. And number 3 is the fact that we don't have a warm-up mode. And then let's move along here and do number 4, which is going back to this diagram here. If you recall, we had this ratio between the outside air and the return air as being like 80 to 20%, that ratio. These dampers have to be very precisely calibrated, and we had a balancing company come in here, and it's not a linear relationship. You can't just eyeball it and say, well, if they're 20% open, therefore it's going to be 20% of the air is coming in there. It's a non-linear relationship when you look at the dampers turning inside of the ductwork, not only because of the fact that the geometry is non-linear, but there's also turbulence going on in here, mixture and different pressures going on, and back pressures. So you really can't just look at those dampers to tell what that ratio is. And these have been turned so many times and been jockeyed around both mechanically and through this minimum outside air, and there's also an air conditioning setting we'll get to that does a minimum temperature here. All these different things have really got these things not only not in lockstep with one another entirely correct, but they certainly aren't calibrated to be precisely 20% of the air volume. And the way the balancing company does that is to actually measure the airflow through here and figures out that ratio, or they can put temperature probes in here and do the math to have the math come out correctly so that the right ratio gives them the temperature that they theoretically should be getting. That has to be done by a balancing company. That's a fairly sophisticated thing to do, and is not something that we should be doing or anybody else should be doing. It was done once. It was done incorrectly, in my opinion, but that was 3-4 years ago, and things have changed dramatically since then. In fact, when they did this motor didn't even exist. It was left out, or it was just, I guess the motor was technically there, but it was not hooked up to anything, and these linkages were just locked down. So they may have calibrated it, but those settings are long gone. So that's not only from a health standpoint, it's really important to have the right outside air mixture and for law, but we don't want any more than we have to have, because that makes a huge difference in the amount of heat that we have to apply to raise the temperature from whatever this mix air is up to what we want for the supply air. So that's a big deal. So that's going to be, what number are we up to here? Number 4, deficiency. And then number 5 is there's an offset, and this is going back here to the same one again. So these all kind of tie together. The heat 1 to heat 2 right now has a stage 2 offset of 4 degrees, which is fine. That would say that if we're at 70 degrees, we're going to fall down to 69, we're going to go into heat 1, but if we fall down to 66, then we're going to go into a heat 2 mode. Normally that would be great, because that says that don't go into heat 2 unless we have a significant drop, and 4 degrees is about right. The problem is that because heat 1 doesn't add any heat content, in fact, it lowers the temperature if you think about it, because if we're at 70, we drop it to 69, and we're bringing in 60-degree discharge air on makeup mode, we're actually going to cool the space during heat 1 mode. We're not going to add heat until we get to stage 2, heat 2, which is going to bring on the full dragons, the full amount of heat. It's not going to do it in a kind of a titrated, gentle way. But if that's not bad enough, it's not going to do it until we get 4 degrees down. So we're going to be at 66 degrees before we get any heat added to the space. That's a pretty big swing. You're going to notice that. So it's going to drop down 4 degrees, and then we're going to have the Santa Ana blast come in and warm it up to 70, and then we're going to let it drop back down to 66 degrees. And it's going to go seesaw back and forth by that 4 degree, maybe even a 5 degree realistically differential, because we have a 1 degree there just for heat 1. So it's really going to probably drop down to realistically about 65 before it kicks into heat. So not only is that not the most pleasant space, because it's going to be like the person running the car heat, where it's full on, full off, full on, full off. That's essentially what it's doing, but we've got a pretty big swing there. That should really only be about a degree, 2 degrees maximum, and that's a pretty easy setting to change in the thermostats. If we're not going to have a heat 1 mode, we should just get rid of it and have heat 2 kick in right away and have no offset for that stage 2. That would be the solution to that, because the heat 1 doesn't really need to control makeup air, because we already have that down here. We're going to already have a setting, this is called fan in the thermostats. If the fan is on, we're in occupied, we're in makeup air mode. If it's an off, we're in unoccupied, and we're not doing makeup air. So that's where that's controlled. It doesn't need to come on or come off based on heat 2 or heat mode automatically. So that really doesn't do anything for us. It just makes things actually worse, as you'll see here in a second. And then heat 2 is where we're bringing in, actually bringing in additional heat. Unfortunately, there's no modulation there, and that's probably okay too, because our furnaces really aren't designed to do modulation for heat mode. They're only doing modulation on the makeup air mode down here. So I guess I kind of have this. This would really be makeup air mode, not fan mode. And that would be number 4. That would be that set point, the stage 2 offset temperature. And that's just simply too large of a gap for that to work efficiently. So let's take a look at what the operating temperatures and set points and actual air temperatures look like, knowing that we have these gaps. And some of these we can work around fairly easily as long as we know that they're there, but they do kind of intermix with each other. They're interdependent, so it's a little bit tricky to run the furnace because of this, where it really shouldn't be. So just to review, we're going to look at the 5 biggest gaps, and we'll look at some additional ones here in another video. But heat 1, stage 1 on the thermostats, when there's a call for heat, there actually is no heat. It just goes into discharge air mode only, or the occupied fresh air setting, where it modulates the flame. Number 2 is whether you're in heat 1 or heat 2. Anytime there's a call for heat, we automatically open the outside air damper and bring in fresh air, regardless if we need to. There is no warm-up mode, and we kind of decide that's probably not that big of a deal, but it is. Stage 2 offset. Normally the 4 degrees would be great, because that would be about what you'd want between heat 1 and heat 2, so we don't have it go into full flame prematurely. But the fact that we don't have a heat 1 really makes this nasty, so we want that to be 0 degrees, because heat 2 essentially needs to become heat 1 since we only have 1 stage. So the heat 2 would become the only stage we have of heating. And this is kind of a wordy here, but the minimum outside air percent setting, those dampers have to be very precisely set, and we know that they're really iffy in terms of if it really is set to what it's supposed to be. So that could be either a health issue or an energy issue, one or the other, and probably a mixture of both, given we have 5 units. Now, interestingly enough, at one point they had workarounds for this a couple of years ago that worked fairly well, whereas heat 1 was the heating mode. We just went into full flame, no modulation, kind of like what heat 2 is now, and it knew about the occupied, unoccupied, so it had nothing to do with the outside air damper. And then heat 2 was the warm-up mode. So this was actually heat 2. So that when there was a 4-degree differential, it would go into full flame and close the outside air damper no matter what. So if you had a bunch of doors open, whatever, it would, and it couldn't make up with this mode here, then it said let's close the outside dampers and get her warmed up here as fast as we can. And then it naturally used that for warm-up mode, because in the morning it would be more than 4 degrees off, so it would automatically go into heat 2, which would be effectively the warm-up mode. So that actually was a pretty good workaround, but that all got disconnected, and we'll go into that in a later video. So let's take a look at, this is what our graph looked like before, kind of a mess. But let's take a look and see how it gets very sensitive now because of these things that don't work quite right. Here, it was pretty straightforward. You just set the temperature. We don't have a warm-up mode, so you would just say, I want to go up here to 70 degrees. It would go into heat 2. We're kind of talking theoretically here before, until it hit the 70 degrees, and then it drop off a degree, go to heat 1, and so on and so forth. But now let's see what actually happens in our world. Okay, we have no warm-up mode, so we're going to be at 55 set point. All of a sudden, at 8 a.m., our set point changes to 70, because we want to warm it up to 70. So we go into H2 mode, because we have a big 15-degree difference here, and that's enough to cause it to go into H2. So again, that's going to turn on the full flame, but also open up the outside air damper, so it's going to be a little bit slow in warming. But it's going to take it all the way up here to 70 degrees, and everything's going to be fine then. Assuming we're in occupied mode, then it's going to switch over to, I'm going to call that discharge air mode, where it's not adding heat content, it's not H1, it's just going to be recirculating and bringing outside air in, and then it's going to use that discharge air temperature sensor and the setting on the side of the furnace to bring in tempered air, so we don't bring in icy cold outside air for fresh air ventilation. And that's going to come in, let's say that discharge air is going to be at 60. So we're going to go discharge air here of 60, and so anytime that we're not in the heat mode, we're going to be bringing in 60-degree air. If we're in the heat mode, we're going to be bringing in air that's about 50 to 70 degrees warmer than the mixed air coming in, which is going to be well over 100 degrees. So I'm not quite sure how to graph that here, but so during this heat H2 mode, during this warm-up, the air coming in is going to be way up here, 100 degrees, which will raise this temperature, the air temperature up of the room to 70, and then it shuts off. Now it continues to bring in 60-degree air, and it's going to cool the space off. So two things are going to be happening, is we're going to lose heat naturally, just through doors, windows, outside walls, that sort of thing, but we're also going to cool the space a little bit because we're bringing in cooler, fresh air. So that's going to drop off here, and it's going to kind of look like this until it hits 69 degrees. Now it's going to go into heat 1 mode. So let's see here, heat 1. Because we've dropped a full degree, which is enough to kick it into heat 1, we're not going to go to heat 2 until we drop all the way down to here. Now, normally you would think, okay, it'll warm it up 1 degree, and it'll go back to discharge air and everything will be fine. But remember, heat 1 in our system doesn't actually add heat content. All it does is brings in outside air, which we already have going on, so it's just going to continue on going down. That doesn't do anything until it hits 65. And that's that 4-degree offset until we hit stage 2 heat. So we have the 1 degree here, which is the set point differential, and the 4 degree here, which is the stage 2 heating offset. And at 65, we're going to go into H2 mode, which will then warm the space up fairly quickly, back up to 70, and then we're going to switch back to discharge air mode. And we'll stay there until we drop down, 1 degree, which is where I'm going to go to H1. But again, H1 doesn't add heat content, so we keep on plummeting back down to 65. We'll go to H2, we're going to warm it back up. So really, H1 isn't doing anything. If we take H1 out and just say that we don't kick on heat until we drop 5 full degrees, then that's what we've got going on here. So that's pretty bad. That says that our air in the space is going to vary between 70 and 65 degrees. It's just going to seesaw back and forth, depending on how much heat loss there is. If we have, it's a really, really cold day, that's going to be, fairly quick, a couple times an hour. If it's also bringing in a lot of outside air, 20%, and it's a cold day, it's going to do quite a few times an hour. It may only be once or twice a day if it's a mild day and we have a smaller outside air minimum percent setting because of the occupancy. So let's run this example for unoccupied mode. And remember, unoccupied simply means that we're not bringing in outside air. We're going to run like a home furnace. When the room temperature drops down a degree from set point, we're going to turn the furnace on, add heat content. When it's up to the desired temperature, the furnace shuts off. And it's just that simple. Normally you wouldn't bring in outside air at all. Our particular furnaces, though, remember, bring in outside air whether we want it or not, if it's in heating mode, if it's adding heat to the room. So I'm going to make our setback here at nighttime actually set to 60, just because my graph paper is not going to give enough space down there to really show what's going on. So we're at 60 degrees is what our set point is, and it's going to be that way all the way across because we're unoccupied. We don't want to warm the space up. And the orange here is going to be the actual temperature of what's going on. So we'll start off at 60, and then it's just naturally going to start dropping off because, of course, it's wintertime. It's going to drop down to 59 degrees. 1 degree down means we go into heat 1 mode. So initially, we're off, doing nothing. Now we're going to go into heat 1 mode, and as we talked about in theory, it should add 1 degree of heat content and the furnace should shut off. It should be just that simple. However, our heat 1 turns on makeup air mode, which means it's going to not add heat content. It's simply going to turn on the blower, open the dampers to the minimum outside percentage, and then it's going to add heat content only to bring up the discharge air temperature to the minimum discharge air temperature. So in that case, it's 65 degrees. So it works pretty well here because we go into H1 mode, and even though we're not adding heat content per se, we're going into makeup air mode, which dumps 65 degree air in there. Now realistically, that's the temperature at the furnace. By the time it gets to the actual space, it's going to be several degrees cooler than that. Let's just say it's going to be somewhere in here. So it's going to raise it up to about here. Now the problem is that's not a really slick way of doing that because we're only bringing in 65 degree air. If you remember, the furnace had a 50 to 70 degree temperature rise, so we could be bringing in 115 degree air And this would heat up, in just minutes, and then it shut right back off again. In this case, it's going to have to run a good long time to get it to go from 59 even to 60, because we're only bringing in air, right in this area here. And it's just going to take a very long time to do that. On a cold day where it's drafty, this could linger on for a couple of hours just to raise that 1 degree. But we effectively do that. And once it hits the 60 degrees, it's going to want to keep on going because we're bringing in discharge air somewhere around here. The discharge air is 65 again. The supply air is probably going to be a little bit less than that. But it's going to clip it off here at 60, or at 61, I guess, with the differential. And it's going to say, okay, that's enough, so that won't actually exist. Heat 1 mode then goes off, and the furnace goes off. And then the temperature just falls off because of natural losses to the room, and then that repeats. Just like that. So that works fairly well. It goes above a degree and below a degree, which is what it should do normally. The only problem is that when it does turn on, we're only going into heat 1, and it doesn't do a proportional setting in our furnace, so it just brings in discharge air that's just not really warm enough to do any significant heating of the space. So it tends to run a very long time. And remember, the entire time it's running here, when it's doing this warm-up little piece here, we're warming 20% or thereabouts of outside air that entire time. So it's just not a very efficient way of doing it, because we're just adding tiny amounts of heat, but we're also bringing in all this outside air. So if this takes it, an hour to raise it those 2 degrees, which is realistically how long it can take on a cold day, 20% of the energy is being wasted because we're bringing in outside air that entire time, because we're in heat 1 mode. Okay, here it gets worse now. If the person who's operating the system doesn't understand this limitation, normally the discharge air is a comfort setting. So if you want to have it at 70 or 55 or whatever, it's whatever feels best. Sometimes I think the actual recommendation is 55 for discharge air, and that way you're getting kind of this cool, fresh air coming in at all times, and you're only adding heat when you need to. And that actually feels probably better in a large commercial space, especially if you're trying to work and so on. But if you were to do that, let's take a look and see what happens. Come out here and say that the discharge air is going to be at 50 degrees, which is the setting on the side of the furnace. So we're at 70, we're coming along here, the furnace is off. We drop down to 59 and we go into H1 mode, which just brings in discharge air again. So it's not going to warm it up because we're at 59, but we're bringing in 55 degree air, and it's going to really be about 52 by the time it gets to the space, which is the supply air. So now we're bringing 52 degree air to warm it up. It's not going to work. It's going to cool it off. So heat 1 is going to keep dropping the temperature, which is a curious thing because we have a call for heat, but we're actually going to lower the temperature. And it's going to keep lowering it until either it hits the supply air temperature of 52 or until it encounters the stage 2 offset, which is 4 degrees plus the 1 degree differential. So that's going to be right about 55. So it's going to counter that one first in this case. So at 55 then, it's going to switch to H2. Well, H2 has a huge temperature rise. Remember, it is going to do the full 50 to 70 degree rise between the mixed air and the supply air. So it's going to heat it up, and it's going to go like this. It's pretty damn fast. Whoops. And it's going to go all the way up to the 60 degrees. 61 will probably go up a little bit higher because of that differential. And it's going to stay going at heat 2 until it gets up there, and then the unit goes off. Okay? And then we start the decay again. But now, guess what happens? We hit 59, and here we're decaying fairly slow because we're only having heat losses from windows, doors, outside walls, that kind of thing. But when we go into H1, it's going to actually speed up because we're bringing in outside air, and we're bringing in, well, not so much outside air as we're bringing in 52 degree air into the space. So it's like opening up a big old window and letting the blast come in, and it's going to cool it off that much quicker until it hits the H2 stage 2 offset, and then it's going to zoom it back up again, and then it's going to gradually taper off, and then do this, and it's going to continue to do that 24/7. Because remember, 24/7. Because we're in unoccupied mode. So we're sitting here oscillating around the 60. So you can see that these are really critical settings where they really shouldn't be. It shouldn't matter what your setback temperature is. It really shouldn't matter what your discharge air temperature is. The offsets between heat 1 and heat 2 are something that engineers should be setting, as is differential is. So these should be user settings that are, for the most part, independent of one another and shouldn't have this problem. But in this case, if you don't understand how they interact with this heat 1 business, not being really heat 1, you have an enormous waste of energy. It's ginormous waste of energy. Lots of dollar signs. Because every time you have a call for heat, if this discharge air is lower than the setback temperature, then you're actually going to be cooling the space every time you call for heat, just so that you can get it cold enough so that it can turn on the full dragon, heat it up, so that it can start cooling off again a little bit, enough to where it can bring in cold air and repeat the cycle again. So that's just crazy. It just goes back and forth, back and forth, back and forth. And this is really what's going on with like the classrooms and the narthex. The spaces that are in the perimeter of the building are really prone to this, because that's where this occurs naturally, because the heat losses in the building. The sanctuary, the core furnaces, and the narthex, or the Ackerman Hall furnaces, really don't have this too much going on, simply because if the perimeter furnaces, the classrooms and the narthex, are doing their job, they don't have to do anything during setback mode, unless it gets really, really cold, because it keeps the envelope at a constant temperature. But in this case, at a tremendous cost, because these things are going to be running probably anywhere from 16 to 20 hours a day each, when realistically they should be running a tiny fraction of that. They should be on for a little bit and then a good long time, because the building isn't that leaky. And in this case, it just fights itself. Every time it heats up, it just cools itself down again and goes back and forth, depending on how these are set. If these are set fairly intelligently, then that effect can be minimized to where it's just this going on. But nonetheless, it is still a waste of energy, because you've got the heat 2. It's always occupied to where it's always bringing in fresh air, and that stage 2 offset really is too big. Although I don't know that the 4-degree drop is a huge deal when you're unoccupied, but it certainly is when you're occupied, because it's going to be it ends up being a 5-degree temperature swing in the space, and that's definitely a noticeable temperature swing.